Hey, good morning, good afternoon, and good evening, everyone, depending on the time zone where you join us from today. I'm so happy to welcome every one of you again at our next session of AI 42, where we are going to learn how to use Excel for data science. And for this, we bring an amazing speaker, Sandeep, who is a simulation and data analytics engineer. Hi, Sandeep, how are you?
Good, how are you?
Yeah, we are feeling great, like I think all of us. And we are very excited to learn from you. And I know that your background was in research in mechanical engineering and product development, and you always use statistics to analyze data, which is, I think, pretty awesome. Have you been using Excel a lot for your researches?
So I have. So I started with Excel, and as the things got more complex, I started using other tools. But what I hope to show in this presentation is the science part in the data science, how I approach the things in using Excel that stayed with me no matter what tool I use. So hopefully the participants will take away the same thing out of this session.
Yeah, that sounds really exciting. I think everyone waits for this session a lot. So, but before we get to your session, we would like to give a quick introduction to AI 42, tell a few words about who we are, and then we come back to you, Sandeep, so we can get started with your session.
Okay.
Yes, so welcome to AI 42. So first, a little bit of intro to who we are. So the background and the motivation for starting AI 42 comes from the fact that we feel that there's really no good starting point when you want to begin with AI. So AI 42 is a strong team here consisting of me, Eve, and Gosha. We're three Microsoft AI MPs. And what we want to do is we want to provide you with a valuable series of lectures that will help you to jumpstart this career into an interesting field of data science and artificial intelligence.
And the concept is simple and involves professionals from everywhere around the globe. There is a new content twice a month that will help you to understand the underlying mathematics, statistics, probability, calculation, and together with data science and machine learning pipelines. With this lecture, you are going to be able to learn everything that will help to land your dream job, as long as it's related to artificial intelligence and data science.
And by creating cross-collaboration with other organizations, we can give the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would be able to support less fortunate people and organizations that are not that recognized yet, even though they would deserve it.
And both AI 42 and also other events, like we had a real-life machine learning conference a while ago, is sponsored by Microsoft and Miles. And we are very humbled and grateful for all the support that we get from our contributors as well. So we would like to thank Levente Pongor, who is the designer behind all the beautiful graphics that you can see in our streams, and also Mina Marie for the cool intro music before our events.
And we are also in close collaboration with C# Corner and the global AI community. So our lectures are going to be there as well on YouTube channel and another our media. And Nicolette taught is create and review all our text content we use on our websites and advertise it and during our session.
You can follow us on Facebook, Instagram, and Twitter to become a part of a growing community where we will share knowledge and fun. So you will find every information that would bring you to an advanced level in the field of AI and data science. You can go ahead and watch our recorded sessions on our YouTube channel and find our upcoming sessions on our meetup page.
And we also have a code of conduct, and you can see on this link, so the code of conduct outlines the expectations that we have for participation in our events and also in our community. And it also includes how you can report unacceptable behavior. And we are committed to providing a welcoming and inspiring community for everyone. So be friendly and be patient and be welcoming and also be respectful of each other. I will post this link to our code of conducts a little bit later on. So with that said, I think we will go back here to Sandeep. Just one moment.
Hi, welcome back, everyone. Welcome back, Sandeep. It's so exciting to see you again. We are going to get started soon with your session, which is about Microsoft Excel in data science. Could you tell us a few words about what we will learn about today?
Yeah, so as I mentioned earlier, what I want to show you is the life cycle, a typical life cycle in a data science project. And then this life cycle will stay with you no matter what tool you use, even if you're using Excel, R, Python, Power BI, Tableau, it doesn't really matter what the complexity is. The structure of the life cycle will remain the same. The type of questions you ask and how you approach a project will remain the same. The good thing about this session is that I will simplify things. So if you are new to data science and understand how to approach a project, how to get started, then I think you will get something out of it for sure.
Wow, that really sounds very valuable. I think it is time to get started. Are you all ready to get started?
Sure, absolutely.
Yes.
Let's go for it.
Let's
Thank you.
get started.
Hello all. Thank you for joining me today. Hello all. Thank you for joining me today. My name is Sandeep. First off, I want to thank AI42 for inviting me here. I've been following them for a while, and all the sessions that they have provided so far in this series have been excellent. So I'm really glad to be here. So let's get started. We have a lot of topics to cover. So let me go ahead and share my screen. Today, my topic is going to be how to do data science with Excel. Okay, so let's get started. So hopefully you can see my screen now. A little bit about myself. I'm a data analytics engineer at Cree Lighting in Wisconsin. I have been doing data analytics, data science for the past 5 years, 6 years or so, primarily using Microsoft Data Stack. So using Azure ML, Microsoft Power BI, Python, R, SQL, PySpark. So everything that I could get my hands on. You can visit my blog at powerbi.com. And I'm also pretty active on Twitter at powerbi. As you can guess from my Twitter handle there, I'm very active in the Power BI social community and the networking. So what exactly is data science? And if you ask me, I mean, my definition is probably going to be different from maybe 10 other data scientists that you talk to. Is it same as statistics? Is it big data? That's the buzzword. Is it machine learning? And if you ask me, it doesn't really matter. What matters is using a data-centric approach to solve business challenges. And the word that I've highlighted here on my screen is solutions, because we want to be able to solve some business challenges using data. Now, the life cycle that I'm going to walk you through today using Excel, it's pretty tool and language agnostic. If you have used Python or R, you will find the process exactly very familiar, and we're going to follow the exact same process in Excel as well. Everything starts with identifying the business challenge. So we'll first identify the business challenge, gather data, transform the data, and this is called as ETL, meaning extract, transform, and load. If you work in a big team where you have data engineers helping you, then in those scenarios, they will do it for you. But in Excel, I'm going to show you a light version of that, how you can do that. Then you do exploratory data analysis, then analyze the data, do lots and lots and lots of experiments. And that's one thing that I think why there is a science after data. Because even when there is science involved, there is a lot of scientific experimentation involved. And that's what exactly data science is all about. You work with data and you do lots and lots of experiments that are with proven methodology, proven life cycles, and then come up with some sort of a conclusion. And then once you have done that, you communicate your results back. And all of this has to be operationalized in a way that it can be used in your own company. So the business challenge that I'm going to walk you through is, let's suppose you are a data scientist or a data analyst and you're working in your company, and the HR department contacted you and they said, hey, you are a data analyst or data scientist. We have collected a data of all of our employees. These are survey results over the past 3 years or so. And we've scored different employees for example, in the first year, they got a score of 0 to 100 by their manager on some sort of a performance evaluation metric. We don't know what it is, but some sort of a performance evaluation metric. Second year, they were graded on a scale of 0 to 200. Third year, 0 to 200. And the final is the score between 0 to 300. And this final score is something that the HR department will take into consideration to create some sort of a development plan. Whether this employee should we promote them or offer them more training opportunities, or what can we do more, maybe perhaps provide them more support if they're struggling, things like that. So what your HR department is looking for from you is, hey, analyze this data, and we have a business challenge that we want to help our employees. So what can we do? Are there any policy recommendations? Are there any insights that you can get out of it? And then we can work together to create some sort of an employee development or retention policy. When you are working with data science, there are different types of projects that you will come across. One is just exploratory data analysis, meaning just get some insights out of it. We are not looking to do any prediction. Then there is statistical analysis, meaning we have some small sample size, and by analyzing that small sample, we want to infer something about larger population. In this case, let's suppose in this case we have the entire population. There are 1,000 people in the company, and we have scores for all the 1,000 people in our company, right? So it's the entire population. If the scenario was, hey, we have scores for only maybe 100 or 150 employees, and we want to analyze that data and then make some inference about all the employees, that would be statistical analysis. And the third aspect is the predictive aspect. The predictive is, hey, analyze this data, and then can you make some sort of a prediction based on the historical data? So which is the case here. We want to look at the 3 years of score and then predict what the final score is. Usually when you're working in a company, you'll have a lot more data than this, but I just wanted to use something that you could relate to and analyze and look at it quickly, okay? When you are working in a company, you should always, before you start on a project, you should always collaborate with your domain experts. And that's something that's very important to understand. For example, in this case, you will talk with your HR person and understand what the scope is, what the scores mean, how were they collected, identify the data generation process, who collected the data, over what period, did they ask the same questions, how did they decide on the scale, and all of those sorts of things. You will also want to understand what are the implications and what is the decision that will be, how will the decision making happen? Meaning, if you create this solution, how will the HR person or the HR administrator, how will they use this data? And that can be that you will use that sort of an information to create your solution architecture around that. In this case, let's just assume that we have the data and we want to create a data analytics solution in Excel and then provide this Excel sheet back to our HR administrator where in the future they will enter the 3 scores and then get an understanding as to what their final score for the employee would be. And based on that final score, predicted final score, if it is on the lower end, maybe they'll say, okay, we have to do something about that. If it is on the higher end, same thing. They can talk to their manager. Should we promote this person or do something about it. So in this case, we are going to predict a continuous value. So that's a regression, and we'll talk about this. Another type of modeling approach is using classification, in which case we predict categorical variables like yes, no, or promote, not promote, or something that is more of a string rather than a continuous number. Okay. So the data that I want to show you today is actually in SQL. And when you think of Excel, you will usually think of an Excel sheet with hundreds of different columns that's already there. But when you are working in a company, most likely all of your enterprise data or the data that you will use to build your models or get some sort of build your insights based on the data will be in some database. And one of the things that many people don't really utilize is the ability of Excel to connect to all these different data sources. So which is what exactly we're going to talk about today. So the way we're going to do that is open your Excel and then click on the data tab. So when I click on the data tab, click on get data, and then I will go to SQL data source. So in my case, if you see, there are lots of different data sources here. So if your data is in PostgreSQL or Oracle, you can even connect to your Azure SQL or a blob storage. So lots and lots of different data sources. So identify where your data is located and then connect to that. In my case, it is in a SQL server that I just talked about. So if I go here and then select the top 100, you'll see in my case, this is the data. Okay. The name of my server is localhost. So I'll connect to that. So give it a second. And this portion of, or this area of Excel is called Power Query. Now what we are going to do is when I connect it to this server, I'm given list of different databases, and I will connect to this Excel DB, which is where, and this employee rating. This is where my data is. I'm going to click on transform data. So let's go ahead and transform the data. And as I mentioned earlier, what we are going to do is operationalize our solution, meaning it's not just one flat CSV or Excel file anymore. We are connecting to the direct data source, extract the data from there. And now I'm going to show you how we're going to transform that data. Okay. So let me refresh here, and I'm going to go here and turn this off. You will see that we have connected to the data. That at the top here, we have the column names year 1, year 2, year 3, and final. Next to that is what is the type of this column is. So in this case, the data type is decimal, ABC is string, and this is a string as well. Let's understand this data a little bit. And the way easily you can do that in Power Query is if you go to the View tab here up at the top, and then click on column distribution, column profile. And as soon as you do that, you're given a distribution of all the different values. So if I click on year 1, you will see, for example, at the bottom here, that word, okay, there are 985 values, no zeros, the min is 3, and the max is 127. As I showed you earlier, by collaborating, when we collaborated with our HR person, he or she told us that the range is actually 0 to 100. So 127 is not a possible. It's not possible, right? So it could either be misentered data, or it could be maybe 127 instead of 127. But we don't know that. But this will affect our analysis. So So I'm going to exclude that, and I'll just click on this arrow, scroll all the way down, and click on 127. Okay. And as I'm applying all these steps, the transformation steps are captured on the right-hand side here with the applied steps. And you can go up and down and then go through each of the transformation steps. I'm going to do the same thing here, year 2. The max is 304, which is not possible. So we'll again click on this. And instead of unchecking 304, I'm going to build a data profiler here. So I'm going to say I'm going to add a constraint to ensure the data quality. So I'm going to say this value is less than or equal to 200. So next time, anything that's above 200 will automatically get filtered out. It won't be entered into our data. Year 3 should be a number, but right now it is showing up as a string. So we need to look at that as well. This is called as schema drift, and it's very common in data engineering and data scientists. So as a data scientist, you'll often be looking at and spending a lot of time making sure that your data quality is good, and which is exactly what we are doing at a smaller scale. But again, as I mentioned earlier, we are looking at a tool agnostic or a language agnostic process. Even if you're using Python, you would be going through the same process, maybe with a different language, but the lifecycle steps are still the same. I see a dash here, so let's get rid of that. And again, same thing. We don't need any here. At the bottom, you see any. And then plus, we are going to add a constraint here as well, because in the future, we don't want anything that's greater than a 200, right? So I'll go here and I'll say it, first we'll need to change it. Let's actually go to final. Okay, so I'm going to go to final. Let's look at, scroll down. Oh, there is a null here. So let's get rid of that. And now we should have only the numbers. I'm going to select all 4, right click, and then I'm going to say change type to a whole number. Okay, and I'm going to add a constraint here as well that, hey, this number is supposed to be less than or equal to 200, so we can ensure the data quality in the future. Interesting thing here is, as I am going through all these different steps, if you right click one of the steps here, you'll see view native query option, the bottom. And what Power Query did here is it folded a query, meaning all these transformation steps, it actually created a SQL query for you. And the importance of that is when you're working with large amount of data, Power Query is intelligent enough that it generated that SQL query and it will send that SQL query over to the SQL server. And when it is extracting that data, all these transformations are done on the SQL server side of things and not in not in Excel, which is really cool. So if you are familiar with Excel, rather SQL, you could do the exact same thing as well if you wanted to when we created the connection. So this allows you to create SQL queries. Now, not all SQL queries will fold. For example, when I change the type, it broke. It is grayed out right now, so it is broke. So all good, right? Now we have transformed our data, and then we cleaned our data. Everything is in great shape. Now, one thing that you should keep in mind when we are doing exploratory data analysis, especially when the goal is to do some sort of a predictive modeling. Our goal is to create a predictive model that is generalizable, meaning we need to ensure that this predictive model that you're going to create, it can be applied to an unseen data in the future. For example, if you create something today based on historical data, how can you make sure that next year, next quarter, whatever the scenario may be, when we have new score results, that data, this model can be applied to that data as well. And the way to do that is if we randomize this or experiment. So if you may have heard about randomized controlled trials or RCTs, which is again a scientific experiment, right? We're going to do some experimentation. That's exactly the same thing that we are trying to do here. We want to create a test train test split, and create a model based on a subset of the data. And then we are going to look at and evaluate our model on a holdout data, meaning another data that we are not going to look at. The important part here is any exploratory data analysis that you do should always be based on your training data. Okay, the subset of the data that you're going to use for modeling purposes. One common mistake that beginner data scientists or data analysts do is as soon as they get their hands on the data, they do the exploratory data analysis, plot everything, and get insights, and then they do the test, their train 10 trace split, which is not correct. Because if you've already done the exploratory data analysis on the entire data set, you're kind of biased, right? You already know what the future looks like, and that's baked into your data analysis, and we want to prevent that. And the way we can prevent that in using Power Query is what I'm going to do is I'm going to go to add column, and I'm going to first create a index column that will just generate an index. I'm going to turn off the column profile. And then I'm going to create another add column, and this custom column, I'll call that as random number. So this is, I'm doing M language, using M language in Power Query. And let's call this as a random number. Okay, so I just typed in number.random. And Power Query uses M mashup language, which is an extremely powerful way of doing data transformations. We won't go into details here. Okay, so we got that created. Now what I'm going to do is I'm going to sort this, and let's say I'm going to sort this by. Remember, we created random numbers, so if I sort, it's going to shuffle all of my rows, right? And then I'm going to just create a reference copy of this, and let's call this as train. Okay. I know I have about 986, I think. So I'm going to right click here, and I'm going to say keep top rows. I'm just going to pick 800. Typically 80-20 split is what we do. I'm going to go here again, create another reference copy of this. And in this case, I'm going to call this as test here. Right click, and now I'm going to keep the bottom rows. So keep bottom rows, and in this case I'm going to say 186, and that's just because we have total 986 rows in this case. Okay. Or actually 176. Okay, so 176. So do that. And now the next thing I'm going to do is I don't need this index 10 column, so I'm going to remove that. That will not affect, unlike Excel, this will not be affected when you remove the column, because everything is done in steps, in a pipeline, sort of a pipeline. So this ensures now that we are ingesting the data, we are transforming the data. Once we have transformed the data, we are going to create a train and a test. This is temporary. This is for now. We will change that. I'll change this later. Okay. And I'm going to do close and end. And when you hit the close button, it is going to load all of this data in Excel. Now, as I'm going through this, if you have any questions, please feel free to drop it in the chat window. I'm also curious to know how many of you use Power Query to do data transformation and extraction. So please let me know. But I always feel that this is one of those underappreciated part of Excel that not many people use. It's an underutilized thing. On the right-hand side, if you see, we have this employee rating, which is the entire SQL data that we imported in Excel. Then we created a train and a test. So we have the train and the test. And as I discussed earlier, we want to look at we want to do our data data exploration only on the trend set, not the entire data set. Okay, test is something that we will absolutely not look at until we have arrived at a predictive model that we want to create. Okay, so the next phase that we're going to look into is we are going to understand the data. And the way we do that is creating, understanding the descriptive statistics. So I'm sure everyone knows about, okay, what is mean, mode, and median, and all of those things. So let's say, for example, if I go to average, and I'm going to look at the average of this column, that gives me 52.3, and I'm just gonna drag it here, right? So it tells me again that what is the overall. Actually, let's look at the final as well. That tells us how our final values are distributed. Okay, so let me move this. Okay, so good, right? Now we can start, but there is a quicker way of doing things in Excel. One way is if I select this entire data that I have, and then go to Data tab here up at the top and all the way to the right, or it could be middle based on how your ribbon is customized. We're going to look at data analysis, which is right over here, data analysis. So I'm going to select data analysis. And in this case, I am going to select descriptive statistics. Okay. So descriptive statistics, my input range is all of this, labels in the first row, and I'm going to call this sheet as stats for statistics. And I want to create summary statistics. Okay. And let's click OK. And as soon as you hit OK, it created a summary statistics for us for all the columns that we have selected. So if we look at it here now, is one thing I'm going to do is a tip for you is if you should always look at always think about what is the meaningful number of decimal points you want to look at. If you have participated in Kaggle, or if you look at all the forums and tutorials, you'll always see people using 25.29325 and different decimals. In real life, we rarely care about the decimals one decimal. It's just one tip that I use. It creates more meaningful comparisons and not getting lost into too many details. So here we have the standard error or mean is 52.5, the median is 53. So very close. So that tells us what we are looking for is how skewed the data is. One quick way to understand that is if you look at the skewness number, if it is close to 0, then it means it is the data is not skewed. And what I mean by not skewed data is, let's say, if you look at the distribution, and we'll look at that distribution, if it is like a simple bell curve or something that is more like this, that is symmetric, that's a symmetrical distribution. If it is something goes like this, it's called a right side distribution. Or if it is like this, then it's a data that's called left data that's skewed to the left. And the importance of that, it tells you more about the data, where the data density is. So we looked at that, and it looks like for our purposes, the data is fairly symmetric. There is not much skewness. Maybe the final is skewed slightly. We also want to look at the maximum. It is 799, 187, 196, and 295. So not too much of, there aren't any outliers that stand out. Another tip is never look at only the numbers in descriptive statistics. You should always plot your data. The way to do that in Excel is if I select the first column, for example, and go to, let's say, insert, I always like to click on this recommended chart options. It just gives you all the charts that are available. I find it easier if I click on recommended charts. It will show all the different charts that are available. So let's say, for example, if I look at this one first, let's look at this one. This one tells me how the data is distributed. And if you look at this one and right click and say add trend line, it's pretty flat, which is one thing we want to note in our case. If there is a trend, then that also tells us that maybe there is some sort of a bias in our data that maybe we should look at. But this is pretty flat, and it is variance is the data is heteroscedastic, meaning it is distributed randomly around the mean. Nothing that stands out. There are some points that are far away from the mean, but nothing that really stands out. Okay, I'm going to delete this. Another very quick way of analyzing the data is if you select everything and then click on Analyze Data button here on the home ribbon, top right, just click on that, and it will generate lots of different, it will analyze the data for you, and this is a quick way to analyze the data. So for example, I see here the frequency of Y1. So this is creating a histogram for us. And as we discussed earlier, I can just click on this and it will drop it in my sheet here. This looks symmetric around maybe like 50 point or 53 or so, as we suspected. Let's scroll down a little bit. Let's see if there is anything else that stand out. Yeah, so for year 3 and final, what it created is what's called as a scatter plot. So in a scatter plot, you plot two different continuous values against each other to see if there is any trend or anything that you can identify. And interestingly, Excel did that for us, and it also highlighted 3 points that may be outliers, may or may not. Outlier is always in a context, is always context specific. And unless you talk with your HR person, you won't know for sure if it is a outlier or not. In this case, if I right-click this and again add a trend line, you will see a trend line here. So this is one of the important things that you want to look at when you are analyzing the data. Is there a trend line? So there are 3 possible things here. That it could be trending upwards, which means there is a positive correlation between the 2 variables. It could be flat, which would mean that there is no correlation. And third, it could be trending downwards, meaning it is in the opposite direction, so up and down. So something like this. And in that case, the 2 variables are inversely proportional in this case. So what this is telling us is as the value in Y year 3 increases, final score also increases. So which is important insight here, right? Because that tells us that a 3rd year score is important. So we can let our HR administrator know that yes, you should monitor year 3 scores very closely, because that is a strong predictor of the final score. Okay. But what about year 2 and year 1? We can do that very easily. Again, if I go to the data, and select all of the data and analyze data, you can actually type things in here. So if you see this window, I'm going to say, let's see, final. We are interested in final, right? So the final versus or final by year 2 as scatter plot. Let's see if that works for us. That's scatter plot. Okay, so that did not work. Let me go back here. So field 4, field 3, I'm not sure why. Oh, that's probably because I should have selected all 3 and then clicked on analyze data. Okay, now let's try this. Final by year 2 as scatter plot. Hopefully this will work. So we'll see. Otherwise, you can try it on your own. But yeah, that worked. So I just typed something in, and it created a scatter plot for me. And you could type something, and then it will give you lots of create different things. So it did the same thing for us. Final versus year 2 looks like there is a good upward trend here. So final year 2 and year 3 do have strong correlation with the final. Another way to look at this same thing is if I select all of this again, and then let's go to data and go to data analysis. And now I'm going to click on correlation and click on OK. Input data range is all of these. Enter labels in the first row, and I'm going to call this as correlation. Okay. And click on OK. Now it created correlation for us. So this is a Pearson correlation, meaning how are these values? So if we look at final, which is what our target is, year 1 is poorly correlated. Year 2 is moderate correlation, 0.29. So typically, I'm going to say maybe 0.2 to 0.5 is moderate correlation. Anything above that, 0.5 or 0.6 is a high correlation. So year 3 is a good predictor of the final score. Year 2 is a good predictor of the final score. Year 1, not so much. Okay, so that's what our main takeaway here is from this analysis. So far we have identified a lot of different things. We've explored the data and then analyzed the data. Another thing that you should always look at, or one common way to look at things, is if you select all of this again, and then maybe go to your recommended charts, and then all charts, and always look at your box and whiskers plot, which is a good way to look at the summary statistics in a very in a quick fashion. So this tells me overall that year 1, 2, and 3, the horizontal line indicates here what the median value is, and all the points here that are above and below the horizontal lines at the top are above the 75th quartile and 25th quartile. It is showing us that these values are maybe higher than the interquartile range. So you should talk to your HR person and understand if these are outliers or not. Okay. And in our case, we are going to just assume that these are not outliers. But if they are, then you will treat them either by removing them or correcting them in your database and then doing something about it. Should also look at if there are any missing values in your data and things like that. Okay, so this is all good. We analyze the data. We have some sort of an insight that, hey, first is there are some problems in our database. There might be some values that had to be corrected. We had to transform the data. So which means that you should let your HR person know that maybe create some sort of a data quality check or do something so that we don't have these issues in the future. Second, we identified that year 1 is not such a good predictor, which is good, because then it tells us that maybe the person, if we do the first year analysis, don't jump to any conclusions after first year scores. Okay. It could also mean that maybe the company training program that they currently have, if they after the first year, they may be working, because it's telling us that whatever is they are doing in the second year and the third year in their training and development, it's working, and it's leading the employee to do well in the final score. So you should focus if there are any employees who don't do really well in the second year, then try to push them harder in the third year, for example, because the third year their likelihood of doing well in the final score is much higher. So very good insights, right? Now, to get to the actual prediction part here, we are going to do a regression analysis. And the regression, we alluded to this earlier, but the way this is going to work is we looked at the scatter plot, right? So imagine you have a year 3 score on the x-axis and final score on the y-axis. And each of these dots are those observations. And we fit a line, which is what we did as well. So this black line is exactly the same line that we fitted here, exactly this line. What we are going to do is we are going to, well, not manually, but what Excel is going to do is it's going to fit different lines and it's going to identify how far that point is from that line and then calculate a square of that and then sum all of those squares. And whichever line has the smallest square, sum of all those squares, is the line that fits best to this data. And that's called as the OLS, that is ordinary least square method. There are other ways to do that, like maximum likelihood, but this is the most common way of doing linear regression analysis. If your data is non-linear, meaning if the data was something like this, then the linear analysis won't work because we're still going to fit a line to that. That won't work. We're only concerned about linear regression in this case. Again, even if it is non-linear, your data analysis life cycle is not going to change. We're still going to do the exact same thing in terms of following the steps, creating data analysis, and all of the different things. For now, I'm going to delete this to make some space here. But in your case, you will create some sort of a report with all the visuals to show to your HR administrator. So to create the regression analysis, what we are going to do is, again, select all the columns that we want to analyze or include in our regression analysis. And then we're going to go to data and click on data analysis and then scroll up down and then click on regression. Regression, Y range is this, and my X range is this, and my labels, and I want to create, and I'm going to call this as regression. Look at the residuals, plots. I want to look at everything, and then click on OK. Be extended beyond the bounds. I'm not sure exactly what that means, but let me Y range is, let's just manually select all the data points. Is this. And my input range, my XY variables are actually this. Say enter, labels, and say OK. And when I do this, Excel is going to do the regression analysis for us. So what it did was actually did the OLS for us. Again, as I said earlier, always truncate your numbers to the first decimal to make them slightly more meaningful to analyze. So the first thing we want to look at is our square value, 0.52 and 0.52. So what R square value tells us is how much of the variance can be explained by the explanatory variable, that is X and Y. Meaning, let's say, for example, if I typed in 23, 23, 23, 23, and if I ask you to make a prediction, what would be your prediction in this case? Of course, 23, right? If I said if it is 23, 52, and then if I just randomly type numbers here, and if I tell you what is the prediction, you won't know. But there is a variance here, right? There is some variability that we want to capture. We want, if we had some more X variables, we will be able to explain what that variation, where that variation is coming from. And that is what this R square value is telling us, that compared to random guess, how well our model is able to explain that variance. Okay, and it's saying it's able to explain 52% of the variance in the model, which is not too good, but it's not too bad either. For our purposes, let's just say it is good enough. Next thing we want to look at is look at the residuals and MS. This is perhaps a better way. If I take a square root of this value and 942, this is much more intuitive. This is telling me that overall the error is about 31 or so. Meaning, if the prediction that I made, it is off by plus or minus 30. Is it good? I don't know. That will depend on your business case, and that will depend on a lot of other things. So, yeah. So that one way to maybe understand that is you can look at the standard deviation in your data, and the standard deviation of our final value is 44, whereas the square root, the RSME is 31. So which is actually not that bad, which is good. We're doing better than the variation, the randomness in our data. The next thing we want to look at is which of these factors are important. So this is year one. So this is Y1, Y2, and then Y3. And the magnitude of this is telling us how important that variable is. So it's saying Y3 is most important, followed by Y2, and after that Y3. So which means that what we got out of our correlation analysis is correct. In our correlation analysis, we found that year 2 and 3 are important. Year 1 is not so much important, which is exactly what we found as well. That year 2 and year 3, where did it go? Year 2 and year 3 are important. Year 1 is not so much important. It also tells us what our linear model is. So in our case, the linear model is actually, because it is a simple linear line, it's going to be this number, or actually let me copy all of this, and I'm going to go to my training. I'm going to paste it right here. And the way you're going to do the prediction in this case is my intercept 15.22, which is if all the scores were 0 for all the 3 years, what would be the final score? 15.22 doesn't mean anything really, honestly. It's just we can call that as a bias in our model. And this year 1 multiplied that by the first year score plus the coefficient of the second variable, multiply that by year 2 plus coefficient of the third, multiply that by 3. And in this case, we need to make sure these are absolute. So let me do that. 3, 3, and that is our final model. So now you can see the final score is 175, whereas our prediction is 160, 114, 116, 159, 176. And these are our predictions. So, and we can actually productionize these predictions. And this is what usually happens, that when you create a model, be it a complex machine learning model that is maybe a deep neural network model, or maybe an ensemble model of 15, 20 different models, you want to productionize it. And in most cases, that is productionized in maybe Azure ML, where you call that model or invoke that model, or maybe you have a SQL Server machine learning SQL Server where you put it in your in database model prediction. In our case, what we are going to do is take these numbers and then put it in our Power Query. So any data that we get in the future will automatically get scored. And the way we do that, I'm just going to keep these numbers in mind: 86, 41, 10, and 15.22. So let's go back to connections here. So if I go to connections, And let's say we go to test and go to edit. And I'm going to create a column, a calculated column. So I say custom column here in this case is just going to be 15.22 plus, I think it was 0.1, multiply that by year 1 plus, I think it was 0.22, multiply that by year 2 and 0.86, multiply that by year 3. The way you interpret these numbers is, for example, 0.86, the way you interpret that is if there were two people who had same scores in year 1 and year 2, for every point that they get in year 3, their final score will increase by amount of 0.86. So if there are two people who had same scores in year 1 and year 2, but if one person scored 1 point, he will get 1.86 in the final result, whereas the other person, if he got 2 points, then it would be 0.86, 1.86 multiplied by 2. So that would be the number. So we click on OK, and now these are our predictions. So let me go make it a whole number, and this is exactly how prediction inferencing works in real life too. That in our test, we called that model and made these predictions. And now any data that we get in the future, as soon as we get that data and we click on, if I go to data and then click on refresh all, any data in the future that you get, it will automatically, this linear model will be applied to that data, and then we will get the predictions. So this is what is meant by operationalizing your model. And the process of this, the entire life cycle that we just followed right now is going to be exactly how you're going to do it in no matter how complex your model architecture is. So I hope that answered or at least showed you how to productionize using Excel. There are lots of different things that I wanted to show, but we are running out of time here. But I wanted to go into detail in one single, using one single example as much as I can, so that you can take something practical out of this session. So I hope you found it useful. If you have any questions, then please let me know. Add it in the chat window, and I will do my best to answer your question. Again, if you feel free to connect with me on LinkedIn or Twitter at PowerBI, and we can stay in touch. So thank you very much again for this opportunity. Yeah.
Hi, welcome back, everyone. And wow, that was an amazing session. And it was really exciting. I actually learned a lot of new stuff today. How about you, Håkan and Gosha?
Yeah, it was really great. I really love the idea that you don't need to install any dev tools and everything you have in Excel, and then you can just do your analyze the data. So it's really, really brilliant.
I also
I
think
agree.
that a lot of people they don't appreciate Excel for what it's worth, what you can do with it. So I think that's really interesting here. And we also have Sandeep is here too, so we can add him to the stream.
Yes, because we have some questions.
Yes. So let me put on the question here. One moment here. So we have one question here. Question from Gabriel. He says, could you recommend when to split the data in train test or when you should use train validation test?
Oh, okay. So that's can you hear me okay?
Yes.
Yes.
Okay, good. Yeah, so that's a great question, and thanks for the question. That's a deeper topic that will likely require another hour. Yeah, so in a nutshell, when you have the reason why we want to do a train test split is, as I mentioned in the session, the test, the holdout set, either the test or the validation and test is supposed to be your unseen data. When you have large amounts of data, in how you define large will depend on the problem you're trying to solve and how much randomness you have in the data. But when you have, suppose you have thousands, hundreds of thousands of rows of observations, in that scenario, just train and test is good enough because you have large data. So most likely you have captured all the randomness in the data. Because when you are creating a model, your purpose is to learn from, pick up the signal as well as maybe some noise and figure out what is signal and what is noise. When you have small data set like what we had here, it would be a good practice to do that. Now in this case, I just wanted to simplify things and not go in too many details as to what is train, validation, test. Yeah, that's a great question. You should definitely think about that when you're doing it.
Yes, thank you. And also thank you for the great questions. We have an amazing audience today, so it's really cool. Gosha, would you like to go with the next question?
Yes, so we have a next question for Elia Glass. So the question is a data analytics is a plugin in for Excel?
It is a plugin, but it is not, it's a part of Excel. So you will have to turn it on. So I think if you go to, by default, it should be there. But if it is not, I think you can just Google, but it is part of Excel. You don't have to install anything new. You don't have to do anything extra. It's there. So, yeah.
Is this analysis tool pack maybe that needs to be
Yeah,
partially
right.
enabled? And then
Correct.
I'm going to share the link in the chat in a second.
Yes, that is the analysis tool pack, and it should include all the t-test, statistic, F statistic, all the different types of statistical analysis that you can do. Regression analysis is there, the data correlation analysis that I just showed, covariance analysis. So all those sorts of things are already included in Excel.
And actually, we also got one more comment here from Elia, who said, interested in hearing further regarding Monte Carlo simulations.
Okay, so that will require another hour. Yeah, so I actually work quite a bit on Monte Carlo simulations as well. And the idea behind those who are not aware of Monte Carlo simulation is randomness is everywhere. Variation is everywhere in every single thing you do. And the reason for doing the Monte Carlo simulations is you simulate those variations, you understand and fit the data, understand what the distributions are in your data, and then simulate things over and over and over again, maybe like thousands of times, and then get some sort of a result and create an uncertainty bound around those values. There are ways to do that in Excel very easily. So for example, if you were to just create a normal distribution, assuming something were to be normally distributed. As an example, if we took the height of all four of us and maybe 300 more people and create a histogram around it, that would be the bell curve, right? And if I were to ask somebody, okay, we pick a person randomly and say, guess that person's height, we can look at that normal curve and then pick a value based on the percentile and then say, okay, this is what that is. And you can always assign some sort of a prediction interval around that. That would be Monte Carlo simulations. And you can combine lots of different variations around that. There is a plugin called Act Risk, Act and RISK that I use. It's a paid software, but it has hundreds of different distribution that you can do in that library. So definitely check that out. If you go to my website and my YouTube channel, Power BI, I gave a session, I think maybe like last year, on how to create Monte Carlo simulations using Power BI. So you may find that interesting. The topics or the things that I explain in that are exactly same how you would do that in Excel.
Nice, thank you.
Thank you. Maybe you could share your link, the links for
Yeah.
your web page, so we can
I'll
put
do
it up
that.
for the audience. Do we have any other questions from our audience?
We can give them a little bit of time here, but meanwhile, maybe Sandeep, because you will be coming back to us next session. Maybe you can give us some information about what you're going to be talking about then.
Yeah, so the next two sessions I'll be talking about. So we started with Excel. We will go switch the gears up a little bit and go over to Power BI and then look at how to do advanced data analytics using Power BI. And in that session, maybe it wouldn't be a bad idea. I can cover Monte Carlo simulation as well using Power BI. We can talk about that. So maybe in the second session, in the first session, I'll talk about data engineering a little bit, creating data models and everything. And in the second session, I might cover some Monte Carlo simulations along with other topics.
Yes. Yeah, so now you're on mute, Eve.
I always do this when I really want to say something. I mute myself. So I'm really excited about your next sessions as well, and I'm very happy that you were here today. I personally learned a lot today about Excel. I think this was the first time I've seen this tool in real life. So it was really exciting, and I can't wait to try it out myself as well. And I strongly recommend the audience as well to share your feedback if you tried out this tool, and let us know if you struggle anywhere. So Sandeep can help you out. And we have another question from Gabriel. So where could we learn more about hands-on Power Query editor?
So a good starting point would be Microsoft Learn, MS Learn. Microsoft Learn has lots of different free guided lessons on their website. So I would go there and start from there. If you get in touch with me on Twitter or LinkedIn, I can share more details with you. But if you're new to Power Query, I would say start with MS Learn first, and that should get you going.
Thank you, Sandeep. And thank you again, everyone, for joining us today. We would like to say a big thank you to you, Sandeep, for joining us also and teaching us something amazing again. And let's hope that we meet again soon in 2 weeks, actually. Maybe we can bring in our slides so we can tell a bit more about our upcoming sessions as well.
Yes.
Sure.
Let's do
Okay,
that.
thank you again for having me. It was a wonderful opportunity, and I'm already looking forward to the next sessions. Thank you.
Yeah.
Thank
Thank you.
And now we are back with one final word that we can't wait to meet you again in 2 weeks to learn from Sandeep about Power BI and advanced analytics. And then, Håkan, could you tell a few words about the upcoming sessions after that?
Yeah, sure. Yeah, so first we have 2 sessions here with Sandeep that he was talking about with Power BI. And then we will have Terry McCann, who will be talking about Apache Spark, how we can use advanced analytics using Apache Spark. And after that, we will have Leila Etati, who will talk about Azure Machine Learning, Azure ML for machine learning.
Yes, because we are going to look into the Azure Machine Learning workspace, which is going to be something amazing, I can assure you. And your journey doesn't have to end here with this session, because we come back with another event also that is hosted by AI42. So we can meet us live in Copenhagen at the Maersk office, where the Global AI Back Together is going to happen, which is a free event organized across the world on the 29th to 19th to 21, but in Copenhagen we will be on the 21st of October. And it is organized by local communities that are passionate about AI on Microsoft Azure. So don't forget, meet us in Copenhagen on the 21st of October and learn about PyTorch and reinforcement learning and a lot more.
Yes, so with that said, we would just like to thank everyone, thank the speaker, thank the audience, and thank all of you who are following us on all our social media and following the events that we do. And we're looking forward to see you in Copenhagen.
Yes, see you all soon.